Good morning, Integrated Math 1. This is for period 4, 5, and 6. And this week I am still on jury duty. Well, today we're going to take you back to Math 8 or in 8th grade, where you have learned or spent a great amount of time in something called slope-intercept form. So today's lesson is lesson 8, 2-1. We're on topic 2 already, a brand new chapter. And it's all about graphing, and we're first going to review what's the slope-intercept form. The objective, it says, we'll be able to graph a line given slope-intercept form and write an equation of a line in slope-intercept form given a graph. But first, let's do some review real quick. So let me take you back to a little bit in 7th grade. So let's start with the things that you need to know for section 2-1. The next thing that you need a review is the slope formula. So back in middle school, you learned the concept of slope, which is a steepness of a line. So if I put a pen like this in this direction, it's a positive slope. Well, this is a negative slope. This is zero slope when it's flat, and when it's vertical, it's undefined. So again, positive, negative, zero, and undefined slope. Well, if I were to ask you to find slope of 2 points that you cannot see graphically, there is a way to find the slope. Is by using the slope formula. So back in the days, you used the letter M to indicate the slope. So this letter M means slope. And the slope formula tells you to subtract the y. So y sub 2 minus y sub 1 on the numerator, and then x sub 2 minus x sub 1 on the denominator. So you're like, what is y sub 2, y sub 1, x sub 2, and x sub 1? So in every order pair, x always comes first before y. So we're going to say this is x, y, and xy. Since this is the first order pair appear in the problem, we're going to put a subscript 1. So that's why you have x sub 1, y sub 1. And then since this is a second order pair, it's going to be x sub 2, y sub 2. Well, we're going to plug in these four numbers correctly into the slope formula. Well, before I do that, it's actually easier for you to draw 4 boxes, and then you fill out the numbers. So that way you don't mess up with the negatives. What do I mean by that? So let's take a look at that. So y sub 2 is negative 6. So we're going to plug in negative 6 inside a box. Y sub 1 is 2. So we're going to plug in 2 inside a box. X sub 2 is 3, positive 3. So we're going to plug in positive 3 inside this box. And then x sub 1 is negative 3, and I want you to be careful. The 3 has a negative, so you're going to put negative 3 inside this box right here. Okay, then after that, you're going to simplify this fraction with the subtraction on the numerator and denominator. Now you can use a calculator. So negative 6 minus 2, if you use a calculator, you get negative 8. And then 3 minus negative 3, that's just same as a plus, right? When you see two negatives next to each other, it just becomes a plus. So 3 minus negative 3, if you use a calculator, you get positive 6. And you also have to check whether you need to simplify the fraction for the slope. Since both numbers are divisible by 2, you're able to simplify, reduce it by dividing top and bottom of the fractions by 2, and you'll get negative 4 over 3. So the slope between these 2 points, without graphing it, will equal to negative 4 over 3. So since the slope is negative, I imagine without the graph, the 2 points, it's going to connect like this, right, with a negative slope. And that's the review that you have to know. Back in middle school or before previous math classes, you learned that the slope-intercept form is in this form, which is y equals mx plus b, where m is the value of the slope, and then the b is the y-intercept. Okay, so if I were to just make a graph of what is the slope, right? Let's say I have a random line like this, okay? Well, the y-intercept would be the intersection of this line and the y-axis. This is the y-axis. And so this point, we call that the y-intercept. So I'm also going to draw an arrow from the words to this point. So this particular point is called a y-intercept. Well, the slope would be the steepness of this line right here, which is shown as a staircase, because remember, slope is just same as rise over run. So this is just same as rise over run. So if I have one point to another point like right here, let's say there's another point here, then to find the slope, all you have to do is count how much it goes up versus how much it goes to the left or right. Okay, so that's rise over run. And that's one way back in the days for you to calculate what is the value of a slope of this line by counting how many times it goes ups and down over how many times it goes left and right. And that would be the value. And remember, slope, right? For the slope, it's usually is in a fraction. It's rise over run, right? And we use positive numerator, right? This is positive if it's going up, and we have a negative numerator if you count it down. Likewise, for the word run, we always count it, it's positive if we count it to the right, and the denominator is negative if we count it to the left. Okay, so these are the things that you have to remember before we continuing the lesson. So that's the slope-intercept form, and every slope-intercept form represents an equation of a line. So every line has a slope-intercept form. Doesn't matter if you draw it horizontally, positively, or negatively. Okay, so with that, we're going into some examples of how do you graph a line by using slope-intercept form. So let's go to example 1. Well, in this example, we have the slope-intercept form y equals 2x minus 1. And we want to remind ourselves, how do you graph this by just looking at the equation? First, I have to identify the slope, right? In this equation, the value of the slope would be the number in front of the x, which is 2. And before you actually graph the slope, you have to make this as a fraction. So to make 2 as a fraction, all you have to do is put 2 over 1. And I noticed that the numerator is positive, so it's going to be 2 units up. Okay? And because the denominator is positive 1, it will be 1 unit to the right. There should be no s on the units, but that's okay. So 1 unit right, okay? So we know the directions of where the graph is going. It's a positive slope, right? I'm not sure how steep it is, but it is definitely a positive slope. But the question is, where is the line located? Because if I were to put it here, 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 they're all positive slope. So we need to have a starting point for the graph. Well, to find a starting point, this is the number that would tell you where is the starting point, which is the -1. Well, for the starting point, we call this the y-intercept. That means on the y-axis, you should start at this number and then use the slope to graph other points on the line. So since it says y-intercept is equal to -1, on the y-axis, you need to find the number -1, which is right here. This dot right here is -1, so I'm going to make it larger a little bit, right, just a little bit larger. And then from there, you count 2 units up and 1 unit to the right. So from here, you count 1, 2, 2 units up, and then 1 unit to the right, and then you graph another point, right, so you make it larger, and keep going. So from here, you go 2 up, 1 right, so 2 up, 1 right like this. And then at the end, you see that those 3 points are on the same line. So at the end, you're going to use a ruler to connect the dots, and then boom, this is the line for this slope-intercept form y equals 2x minus 1. Well, another example, example 2, if you have y equals -5/3 x plus 2, since the fraction is negative, you have to decide, do you want to put the negative on the numerator, which is on the top, or do you want to put the negative on the denominator, which is at the bottom? So you got 2 choices. So this equation is just same as either y equals -5/3x plus 2, or you could write it as y equals 5/3x plus 2. You could only choose one place to put the negative in, either top or bottom. You cannot choose both. Well, let's say if I were to choose the first one here, if I were to graph this, well, it tells me that I need to start on the y-axis at 2. So remember, this is your y-intercept. So I'm going to use the 3 letters INT as the abbreviation for the word y-intercept. So since it says +2, I'm going to start from the origin, go up 2 units, and then plot the point, right? So this will be the y-intercept, +2, +2. And then from there, I need to find the directions of where is the second point by looking at the slope. Well, since the 5 is negative and it's on the numerator, it's going to be 5 units down. And since the 3 is on the denominator and it's positive, then it's 3 units to the right. So from this red point here, I'm going to move 5 down, 3 to the right. So let's count it together. So starting here, 1, 2, 3, 4, 5. And then out from here, you count 3 to the right, 1, 2, 3. And then boom, this is another point. Now if I want, I could move it again by creating the third point by going 5 down, 3 to the right. But if I were to do this, I'm running out of space, so I am not going to plot the third point. So at the end, all you have to do is to connect these 2 points together using a ruler, and then boom, this is the line for the slope-intercept form y equals negative 5/3 x plus 2. Okay. Now, of course, if you want to use the second equation, in other words, if you want to move 5 up and 3 to the left, it's going to give you the same graph anyway. You're just going to have a different point. What do I mean by that? So let's say if I were to start from the middle, if I were to move 5 up and 3 left, again, it's 5 up and 3 left, then I'm going to get to this 1, 2, 3, 4, 5. 1, 2, 3. And this point right here, I know that if I were to extend my line a little bit further to this line, to this point, then I know that these 3 points lie on the same line. So you could either do it this way or do it this way. They both will get you the same line anyway. In example 3, we're going to work backwards. Let's say if I were to give you a graph, well, how would you find me the equation y equals mx plus b? Okay, well, there are 2 numbers that you have to find, which is the value of the slope, so something x, right, that's the slope, and then plus the b, which is the y-intercept. The y and the x, they stays the same, right? They stays by itself because these are not numbers, they are just variables. But for the slope, all we could do is we could count the rise over run, and then for the b is we're going to find which number is this line intersecting the y-axis, right? We're going to find a number that is the intersection of the line and the y-axis. So let's find a b first. I think b would be the easiest to find. Well, all you have to do is you have to look at where the line crosses the y-axis. So these 2 intersections would look like it's located right here. So here is your intersection, and then you're going to count what is the tick mark on the y-axis. So it's gonna be 1, 2, 3, 4. Let me count it again. 1, 2, 3, 4. So since the line in the y-axis intersects at the number 4 and it's positive, you're gonna put positive 4. That's it, right? Plus 4. And then to find the slope, all you have to do is just do rise over run. So from here, how do you get to this point? So you literally count. So I'm going to count 1, 2, 3. So I know that I went 3 down, and then from here, how many times I have to move to the right? Let's count. 1, 2. So it's 2 to the right. Well, since it's 3 units down, the numerator of the slope would be negative 3. And since it is 2 units to the right, the denominator of the slope would be positive 2. So it's going to be negative 3 over 2x plus 4. Okay. If you want to put the negative in the middle, that's fine too. You can just write or y equals negative 3 over 2x plus 4. Both answers are acceptable. Okay, so this is how you find an equation by looking at the graph. First, you find where is the graph intersecting the y-axis. You're going to find this number, and of course in this class it's going to always be a whole number. No decimals, no fractions. And then for the slopes, sometimes it'll be a whole number, sometimes it'll be a fraction. So you're going to count rise over run like this to find this fraction right there. Alright, this is an extra example, which is example 4. Here you're going to see a graph where you have 2 points, and it looks like the y-intercept is not a point, but it seems to be crossing at a tick mark, so we know that it's going to be a whole number. So remember, the slope-intercept form is y equals mx plus b. So to find b, which is the y-intercept, we look at the y-axis and see where is the line crosses the y-axis. Well, it's not at 1, it's not at 3, but it's like in this tick mark, which is between 1 and 3. So the y-intercept is 2. So that way we know that the b here in the equation is positive 2. Now let's talk about the slope. To find the slope, remember, you have to do rise over run. So I will go from the lowest point to the highest point. So to go from the lowest point, I need to go up and down first. So in this case, I'm going to go up 2 to get closer to the second point. I'm not going to go down. I'm just going to go up 2 times. So I know that the numerator, because remember, slope is going to be a fraction. There's an x there. Well, the numerator of the slope, it's going to be positive 2 because it's going up. And after you go up twice, you're going to definitely not move to the left, but move to the right. And you're going to count how many times you're going to move to the right to get to the other point. So you're going to count 1, 2, 3, 4. So it seems you're going to the right 4 times. So therefore, the denominator of the fraction for the slope, it's going to be 4. Now, even though you found all the numbers, you always have to check, well, can I reduce this fraction? In other words, can I reduce 2 over 4? Is there any common factors for the number 2 and 4? Since they're both even numbers, of course there is. You could divide top and bottom of the fractions by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So therefore, your final answer is going to be y is equal to 1 over 2x. So 2 over 4 reduced to 1 over 2. So therefore, your slope-intercept form is going to be y is equal to 1/2 x plus 2. And that's the equation of a line. So always you have to check, can I reduce the fraction? If so, you have to reduce it. Otherwise, it's going to be wrong. Well, that's it for the lesson. Your homework today is going to be on Delta Math, which is titled Lesson 8 2-1 Slope-Intercept Form. And even though there's not much work you have to show, you have to copy the problem. If it's a graph, you're going to copy the graph and write me the equation of a line. If it's asked you to graph it, then you're going to copy the equation and then you're going to generate the graph. So that means each problem, I need to see one graph and one equation. I repeat, in every problem, I need to see one graph and one equation. That's it. Thank you.